I am so excited. We are very fortunate to have this next speaker amongst the people writing Unison. He's well known in many functional programming communities. So I'm glad he's near. I'm so glad he's here, not just because we really needed a command line parser in the ecosystem. So please welcome Eric Torreborre to the stage for this next talk.
Thanks, Rebecca. So yeah, let's go. So this is a presentation about the library I wrote called Potions, and that's a command line parsing library. And if you wonder about the name, it's a not so clever anagram based on options, potions options. And I started this kind of as a detour because my main goal is really to write a Unison service to import some of my bank transactions to my accounting software. That's my original goal. But I realized that I probably would need some kind of input parsing and command line inputs for this application. And I thought, well, that shouldn't be a problem, right? Because parsing arguments and turning them into a data structure, that's not really a thing, right? So I started writing this library to just for myself. And it turns out that command line parsing is not so straightforward as I think, because there's no real standardization around in that domain. For example, if you consider the data structures that are used in various libraries for parsing arguments, you will find different names. So in Rust, the clap library uses something called arg that represents everything. In Haskell, you have names like flag, option, argument, and switch that are different things. In Java, you find something like option in one library, and in one other library, you have something called parameter. And that's the name you're supposed to parse on the command line. So the vocabulary is not really standard around those things. Another thing that's not really standard is the set of features that you can support or that you're supposed to support as a library. So that's the list of what I'm currently supporting in the library. And some of those features are present in other libraries. Some of those features are not present in other libraries. For example, declaring an option with minus option name equal a value. Some libraries just don't support it. And sometimes some command line applications want something like this. The same thing with, are you allowed to repeat an option name or the command line or not? Some libraries support it, some don't support it. So that's the list of things that are currently supported by Potions. And it's not even actually mentioning all the possible features because other libraries can generate man pages. Some libraries support a notation where you can put minus arguments at the end of the command line invocation. And then there's a whole subject of being able to derive parsers directly out of your data structures, which we cannot do right now in Unison. Another thing that's totally not standard is how you represent the help. So this is an example of clap using in Rust. So you see usage arguments options. That's the AWS CLI, which displays clears out the terminal to display the help. This is JQ, and this is Snow, which is the command line for the Snowflake database that has a bit more color, for example, and different definitions for all the sections that can be represented. So anyway, I took some inspiration from all those libraries to create this one, and I want to make a quick tour of the library today. So how does that work? You write a command line like a command like copy, some options minus source in source file and then a destination file, and you want the copy command to copy one file to another path. That's it. So the application is supposed to parse those arguments and then do the copy. The other big use case, of course, is also to display the help. So if instead of passing arguments, you put minus help, then boom, it's going to display the full help. So that's what the library does at the moment. And how is it implemented? Now let's see some real Unison code. So when we do parsing, we want to go from textual arguments to some real well-typed code, like copy in that case. And we want the parser to generate the values for those arguments. And this is the parser for the copy command. So we have here a function telling us that this is a command, that the name is going to be copy. There's a section for the help. And then there are 3 sections for each of the attributes that we want to parse. And those are parsers. So we eventually invoke them to get the actual values that we want to put in our copy data structure. And all of this returns a copy, but with a parsing effect. There's a parser effect in there. Now, if we drill down inside the definition of an option itself, so that's the source option is saying, okay, we want to parse a file path, and we give some metadata. We say, okay, the name of the option is going to be source. You can have a short name with just -s. There's some help text, and then there are some definitions for what it even means to decode a file path from text. And actually, those declarations are already given by the library. So for parsing, decoding a file path, you have some declarations like, okay, what is the decoder? What goes from text to file path? There's a bit of metadata for, okay, that's a file path. How to display a value of type file path as a string, so that you can round trip between an encoder and a decoder. And then there are some examples of values of that type that you can give. And as we will see later, it's important to be able to give at least one example of those values. So that's for the file path, and it's actually the library out of the box has such declarations for most of the value types that you can find in base. So nat, int, float, all of this is done. One thing to mention, which I think is quite useful, is that there's also a format declaration. Since everything you pass on the command line is text, it's generally like values serialized as text. It's nice in some cases to be able to say, okay, what is the exact format that is expected for a given value? I think it's a nice piece of documentation to have. You are, of course, encouraged to bring your own data types to the library, and it's not hard to do. So instead of having commands that are full of fields that are just text, you can have your own product ID, customer ID, whatever, as well-typed values. And at least in order to decode them from the command line, you need to pass a decoder, something to display those values. And then, as I said, at least one example value for this type of values. You can also reuse some combinators in the library. For example, if you have this declaration for product ID, you can also make it a list of product IDs. So have one option called ---- product IDs, where you pass all the product IDs separated by a column, for example. So the list of combinator is going to reuse the previous definitions and now give you a definition for how to parse a list of product IDs. There's also a combinator for optional values, where you can say, okay, if no option is defined on the command line, I'm going to return none instead of some product ID. So now we have ways to decode values from the command line, but we need to turn that into parsers. So we need to tell the application where to get those values from. So we've seen that there's an option declaration that does this. And so you declare that you want an option, you provide a name for that option, a short name, you give the values decoders for file path and a help text. If we look now at the destination option, we can see a small variation. So you can actually put several names. So each option can have some aliases, and we know in Unison that names don't matter. I mean, it's nice to have aliases, but in that case, it's also quite useful if you find out that a name is not great for an option on the command line. You might want to specify another name later on, but maybe you don't want previous invocations to be broken. So this is a way to kind of preserve some backward compatibility. So options are for things that are delimited with ---- and a name. And then you have flag, where you also have ---- a name or just minus a character. But when a flag is present, there's an active value that will be selected for that flag. You don't need to specify one on the command line. And so flags are kind of on-off values. And since most of those flags are kind of isomorphic to Booleans, there's a shortcut for a flag that only works with Boolean values. That is a switch. So a switch is a flag just for Boolean values. And finally, you have arguments, and arguments are everything that is positional, that is not delimited by a minus name somewhere. So you can specify that your source file is just an argument in the list of arguments. So it's going to be the first piece of string is going to be passed as the source file. But you can also specify which position you're expecting this argument to be found at which position in all the argument list. Okay, so now we have specified how to decode values from the command line and where to find them. There's another place where we can find them is from environment variables. And I mean, I found this particularly useful to be able to override my command line application with some kind of environment. So here there's a convention. So by default, if you have a name like source-file, the default environment variable name for that thing will be to uppercase everything and instead of the dash, put an underscore. So you will find your value from source_file. You can customize this. So you can say, okay, I want just to grab my environment variable just from the source name. And you can also apply a transformation on the option name and say, okay, I want to take the option name, mangle it a bit, add the prefix, and that will be my environment variable name. So there are a bunch of functions in the potions.txt namespace that you can use to do those kinds of transformations. So yeah, the environment variables are useful. Another feature which I found interesting to implement is when your flags are not quite isomorphic to Booleans. So if you want to have like a color flag where you want to say, instead of writing minus color blue, minus color green, you would just like to say minus green, minus blue, minus red. So it's actually possible to do something like this. And this is the kind of definition that you will have. So we reuse the fact that you can pass several names, and we need, in that case, to exhaustively list all the names that can be expected for that flag. And we also reuse the fact that we can define examples for a given type. And in that case, we pass all the values for that type, all the variants of that enumeration. And we also know how they are displayed. So basically, we have all the information we need in this flag definition to know that if we see minus red, we will know which value of type RGB will actually render as red. So we know which one was selected by the user. And the help is going to be a bit specific in that case, because there's not only one flag name as it is, generally. Now we have several possibilities for the flag names. So in the usage section, I just give the short names, and the more detailed options section, I give also the long names for those flags. Okay, what else can we do? Oh, so we can do repeated options. So this can be useful if you have, say, a list of product IDs that you want to pass on the command line, but you don't want to, as I said before, separate them by a column or comma. You want to say product ID P1 -- product ID P2 and so on. And you want everything to be collected as a list. So this is one use case. Another use case where you would see something like this is when you want to indicate some levels of verbosity. -V is verbose, -VV is more verbose, and VVV is like very verbose. And we want to collect those values as lists of A instead of just A. So typically we would decode all of this into a structure where all the attributes will be lists of something. And the declaration is actually not very different from what we had before. We just need to put an S at the end of the previous declarations. And that's quite cool because that means we can reuse almost all of the same code, change just one letter, and now we have repeated options. Okay, so what we've seen so far is how to declare options, flags, and so on. But many applications, they have more complex commands and they have subcommands. So in that case, we want to be able to compose smaller commands into larger commands. So there is an operator for this, which is this kind of starship operator, which you would find in the library like opparse applicative in Haskell. It's basically declaring that you want to alternate the parsing. You want to say, try to parse a copy command, and if that doesn't work, try to parse a list command. That doesn't work, try to parse a grep command. And all of those are subcommands of the fs command. So you can nest the commands declaration in this kind of DSL for parsing in order to build a tree of different commands. And the fs command also has its own independent help. And how will this render in terms of help? So the fs help will list all the available commands. And if you look for a specific command, it will just show the detailed help for that individual subcommand. Yeah, another feature, I think that's the last, which I want to show today, is fixing typos. And I stole this from the clap library in Rust, because in the clap library in Rust, if you make a typo for one of the options, it will tell you, because it knows all the possible options, it will tell you, oh, actually, maybe there's another option that has a very similar name, so maybe that's what you wanted to type. And I think that's a nice feature to have. So that's a tour of what the library does. And I want to talk a little bit about how it's implemented. So, I mean, it's not really a secret that in Unison, we don't have so many ways to write abstractions, to abstract over things. We don't have type classes at the moment. There's no way to do real metaprogramming with Unison. All we have is functions. A function is a way to abstract some code, and abilities. Abilities is like a super magic trick that we reuse all the time in Unison. So I want to show you different ways where abilities are used in the implementation of the potions library to do what it does. So the first thing we're using the abilities for is to construct options, flags, and arguments. And those things are inside the library, they are mostly the same, because an option and a flag and an argument, they share help, they share lots of information, but they are also very different, because an option and a flag are named, but the flag has an active value, which is the value used when the flag is on the command line. An argument doesn't have a name, but it can have a position describing where to grab it. All of those three, they have at least one example, and they have an optional default value. So there are many things that are the same and a few things that are different. So here is the data structure that we want to build out of all the declarations that you've seen before, where many fields are very common to everything. And then the first one is specific to each case, a flag, an option, or an argument. So what we want to do is take all the declarations that we've seen before and transform it into this data structure. Those declarations come from abilities. So this is one of them, the name ability, where you have functions to declare names, a list of names, short names. And there are quite a bunch of those abilities inside the library. And fear not, there is one namespace called DSL where all of them are present. So you can go DSL dot, and you will see the list of everything at your disposal. But what we want to do is translate all those declarations into one big option object, if you want. And the way to do this is to write a handler. If we are using abilities, we want to interpret all those abilities into one option thing. And we write this handler by going through all those declarations and then grabbing the information for each declaration and setting them on this option that we pass from declaration to declaration. The thing is, what we get might actually fail, because if the user wants to build a flag or an option, they need to at least give a name for it, right? If there's no name, we cannot build a proper option for those things. So we are really in the case of having a builder pattern. You start from an empty object, you put some declarations saying what you want to build, and at the end you call build, and that builds and validates that object and giving you back a properly built object. So the equivalent of build in the, I don't know, Java land, in that case will be really the make option handler. It's actually a bit more complex than this, because we are actually doing the building in 2 steps. So the first step is building a data structure that contains everything. And the next step is just doing the validation and then returning a proper data type, which is the one that we want. So now we've seen one way to use abilities, which is as a kind of builder pattern in Unison. Another way, which I think is actually quite cool, is to be able to take some of those declarations and reinterpret them as slightly different declarations. So this is what we do when we declare repeated options, where now we want to parse not only an A, but now a list of A's. And this is just another handler. So we go through the declarations for how we want to decode values and how we want to declare value types, for example. And that says, okay, if you know how to decode the value of type A, now you can also know how to decode the value of type list of A. Similarly, if you know how to display a value of type A, you know how to display value of type list of A. You just put an asterisk at the end of the type. That's how you display the repetition. So this is a very powerful way of using abilities, is this a possibility to reinterpret expressions that we have built using abilities. That's really some magic power here. But wait, we still don't have a proper parser. Right now we have just an option type that encapsulates specifications about the parser, what we expect from it and how we document it, but we don't have the actual code to parse stuff. So in order to do this, there's another ability that declares a small language for parsers. And that ability says, okay, you can create a parser either by giving me an option or giving me an option, or possibly create a failure, and then have some combinations of those things, either by using or, which is try one parser or try the other, or using some kind of sequencing of those parsers. That's the language we want for parsing. And then once you have an expression for a parser of A, you can interpret that expression as a real parsing activity where you get some inputs called lexems in that case, but that's just the list of arguments coming from the command line. You get your expression for how to parse them. That's supposed to return an A. And the way you interpret it, you will eventually return an A, but maybe not. That might fail if one option has not been specified on the command line. So you have an exception effect. You can also have an environment effect to take a value from the environment. And there's also a store effect, because as you consume lexems, you have less of them. So we need to track the consumption of arguments. But as we've done before, there's another way of interpreting this parser exception, which is now to display the help. So you can take the same expression that describes how you want to parse things, that says, okay, I want to parse the copy command, and then the list command, and the grep command, and so on. But now you just want to interpret all of this as some help text. So the way you do this, you define a data structure that's going to hold all the help information, some name for the command, for example, all the options for that command, all the subcommands. So this is a recursive data structure that you want to build here. And then you create a handler called makeHelp that's going to interpret the parser. In that case, you don't really care that it's returning an A, because we just want to return some help. And that's going to go through all the declarations to get all the help elements. It's actually not so trivial. I had to spend a bit of time because we are building a tree data structure out of some kind of, like linear declarations of things that are implicitly more or less recursive. You can actually read Paul blog post recently that he wrote about GADTs in Unison, because there's a very close proximity in how to parse GADTs as some kind of ADTs eventually using abilities. So please read that blog post. It's very close to what I'm doing here. And then another thing where I want to shine some light on is I said previously that we need at least one example of each parser, and that it was really important. It's because the way we handle expressions is by focusing on one effect at some specific place. So let's say we want to parse the source attribute. We have some interaction. We run the effect, which is read the value from the command line, try to decode it, and so on. And then if we have a value, then we can run the rest of the program. That's the K continuation that you see when you handle an ability. But in order to run the rest of the program, we need a value of type A. And when we make the help, we don't really have a value of type A because it's not coming from the command line. So it has to come from somewhere. So this is why it's important for every option to have at least one example value, is to be able to trigger this continuation of type A so that we can analyze the help for the source option and then go to the rest of the program where we have all the code for the destination option and then the force option. So I think it's important to have this model of continuations in your mind. So that's how abilities are used inside the library. I'm also using another very cool library in the Unison ecosystem, which is the Terminus library by Renard. So it's library for interacting with the terminal. And basically, as you've seen possibly in some of the declarations, all the help can use Unison docs. And I've written a translation between Unison docs and the print line facilities and that you can find in the Terminus library. So once this is done, that also means that I can inject all sorts of styling into the result. And all the elements that I'm using to display the help have some kind of style declarations that are present in a default style object. And that thing is injected in the production of the help. That means that you can change it. So if you don't like one of the styles in the library, you want something to be bold or a different color, you can just do it. And actually, because maybe you don't like my color scheme, you can even just inject just a palette of different colors, change the shade of blue. If you cannot read it properly, you can inject a new one, and that's pretty easy to do. The last thing in terms of features is how is this thing with typos implemented. So I totally cheated with this. I had a look at the clap source code in the Rust library. I saw, oh, they are using a string distance that I didn't know about called the Jarrow-Winkler distance. I previously implemented something called the Levenstein distance or edit distance, but it turns out that this one is much better suited to finding out typos for short human names. And if you look at the equation at the end, the formula at the end of this text, it's actually pretty easy to implement. It's not very hard. So it was really a pleasure to implement this using Unison. So yeah, that's for the implementation, a tour of the library. And I want now to say a few words about the development of the library itself. And it was my first large Unison library. I implemented a very small one before, just to better understand how the whole editing publish cycle was working. But this one is a bit larger. So I think it's 8,300 lines of code. So it starts becoming something. And I must say that I started feeling some pains while developing that library. I want to share those pains with you. Probably most of you will know about that already. So one thing is there's no full text search really that you can do on the library. Which is annoying because if you have an error message coming from one of your errors in the library, you cannot just grab a substring and go Control F and know exactly where in your code that thing was produced. The best workaround I found for this was to do edit.namespace, the whole library, open this in a new file, and then do Control F in that file. But clearly, that kind of thing cannot scale, right? If you have more and more code, that's not going to scale. Readability, I found, was a bit of a problem when you start. I mean, we know that we spend lots of time reading code. And I mean, one cool thing about Unison is that we don't really care about formatting. You can write some code and you know that eventually Unison will do its own formatting. But sometimes it's less than optimal when you read back some code you've written because it comes back in a very compact form, sometimes with some prefixes that you are not helping the legibility. Also, at first, I didn't know how to write commands. Now I know there's a workaround for this, but I'm kind of wondering if we should not add commands to the AST, if that would make sense, especially given the kind of workaround that we have for it. And even, I mean, having some new lines and separating blocks inside functions visually, for me, it's a way to better understand the code. And some of the examples I've shown in those slides, I had to rework them to make them more readable. I found that navigating code could be also problematic and not so easy. So just one quick example is if you trigger view and you want to look for a function that you think does something, you don't actually see right now as you do view the full type signature. So you're going to think, oh, maybe format is the function I want. So you look for everything, you select format, and then you realize it's not the right one. So then you have to type view again and go and do all the selection and maybe find another one. So small paper cuts like this, but I have the same kind of cycle can be annoying with looking for dependence of a given function. So that can become tiring after a while. Also, fuzzy find is nice, but if you forget to exit the fuzzy find and you start editing code, then boom, all your editor is UCM console becomes scrambled. So that's not nice. Another thing which I found pretty annoying is if you try to view something or get some test results to get some kind of context or for something you want to work on now, you go back to your editor, you start changing some code. Now all your type check errors go to your UCM window, and the context you were having is lost. It's going up in your console. So you have to scroll up or run view again or run test again to know exactly what you are trying to fix. Again, more paper cuts. Something that I think was more annoying, and especially at scale, is when type checking fails. So you write a piece of code and that triggers some errors in other parts of your code. And then I had like hundreds of lines coming up in my editor. And that was showing me, I mean, one compilation error at the time. And sometimes the next compilation error will be, hundreds of lines at the bottom of my screen. And I would spend time scrolling up and down and so on. So that was not great. And also because I had lots more code in my editor, all of a sudden the performance will also become sluggish, not good. But maybe the worst thing was that I was starting to fix things and maybe press update again, and then had other type check errors. And then boom, maybe thousands of lines will just now pop up on top of the previous thousands of lines I had before. And sometimes I didn't know exactly, I wasn't sure if what I modified was still there, had disappeared, I had to re-update things again. And I'm pretty sure I lost some code at some stage trying to figure out what was going on with this cycle of fixing type check errors. So I think that can be improved. Same thing for when refactoring records. And if you've tried to remove a field in a record, that was not necessarily a very pleasant experience. We don't have yet any notion of commits. I know that's coming, but it can be very useful to be able to provide some kind of context to the 10 previous updates on your code base to know exactly what you are trying to do at this stage. Some minor annoyance. If you want to test something, you have to update first, and then you have to test and maybe find out that what you are trying to do is going to fail. So then you need to remember to write the correct version of that code and re-update that version again, and not make mistakes in between, or do a ref log reset or something like this. And the other thing which was annoying was rendering docs. So I think in short, what I want is what we've been shown before is a nice idea. I think we would do a lot better with separate windows for different things, for tests, watches. I mean, it's great that it's coming up. That will help with navigations to have specific actions that you can do on elements to find dependence. And it's great. I mean, my dreams are going to come true. and status adornments to know exactly what is the status of a piece of code. Is it up to date? Is it stale or not? That is uber important in my mind. So yeah, please give me an idea right now. I would love to have this. So I think I'm just on time. So thank you very much.